hit record or whatever. Yep, we're ready. Thank you.
So I reduced it, but then when you multiply it, is it, think I get mixed up with the adding and the multiplying.
Okay, so you said you reduced this first?
Yeah, both of them.
Okay. Remember, one of the cool things, yeah, I need your slips, folks. One of your cool things, and I also need you to get your papers out that I had you get signed. I need to check, make sure I signed it. Is we can do this problem in lots of different ways. So Maggie said, I'm choosing to reduce each fraction individually. Okay, perfect. So she looks at this first fraction. There's a 4, right? Nothing much to do with that. She's got 3 A's over 2 A's. Well, there are more A's on the top. Would you agree? There's one more A on the top. So I'm just going to put an A on the top. These are going to cancel out and leaving me with an A on the top. Likewise here, I've got 2 extra B's on the bottom. So is everybody okay with that? We move over here, we do exactly the same thing. So I got a 3 and a 2, not much to do with those. B squared over B to the 4th, that's going to leave me with a B squared in the bottom. And an A squared in the bottom because there's nothing to do with him. Now, Maggie says I need to put these together. Remember when you multiply fractions, it's top times top, bottom times bottom. So the bottom is going to be 2A squared, and then here's where Maggie's question came in. She said, I've got these B's and these B's, and I'm not quite sure what to do. Well, you all memorized the rule that said when you multiply like bases, in other words, when you multiply B's times B's, you add the exponents. But there are times when we multiply the exponents, and we get all confused. So just use your common sense. What does B squared mean? B times B, right? B times B. How many B's do I have? 4. So even if I don't remember the rule, I can figure it out by writing it out, right? Always, always, always. Now, what'd you say, 4? Now, I've put it all together, but I'm still not done because now it reduces again. So now I've got 12 over 2, which is 6. A, this is 1A, this is 2 A's, so there's going to be an A in the bottom and a B to the 4th in the bottom, and that should be your answer. Now again, I want to emphasize, kids, that the coolest thing about math is there's always more than one way to do the problem, so you did not have to do it in the order she did it, but you had to get that answer. Okay, so if you did it in a different order, you're good, it's fine, as long as you came up with the same answer.
So you can just multiply.
Exactly, yeah. Had I been doing the problem, I probably would have done that, combined them, because that sort of saves me a step. If I combine them first, then I reduce. You reduced, and then had to reduce again. It's fine, it's fine. All right, anybody else have an issue?
51.
51. Our exponents are annoying us, it seems. All right, how did you start it? Could you even begin it? Okay, and when you flip it, flipping is absolutely fine. This guy is to a negative power, so I'm going to put him in the top. Now, here's where we run into problems sometimes. When you move him to the top, absolutely nothing changes, except that exponent becomes positive. Similarly, when you move him to the bottom, which you will because he has a negative exponent, nothing changes in the thing you're moving. Okay? What did you do next? Oh, well, let's just kind of use our, just think about it for a second. All of this gunk is being raised to the second power. So when we have multiple things being raised to a power, we kind of like distribute that exponent, right? So this is where, okay, now let's go back to Maggie, because here we go. This is her question. She says, oh, I got these 2 exponents. Do I add them or do I multiply them? Well, the rule says you multiply them. But if you forget the rule or it gets all confused in your brain, remember, y to the 6 squared means y to the 6 times y to the 6, right? That's what it means. This would mean y, I'm not going to write them all out, but 6 y's. This would mean another 6 y's. So what am I going to have all together? Y to the 12. So if I forget my rule, I'm not going to just guess because then I might miss it. I'm going to figure it out. So this is going to become y to the 12. This is going to become x to the negative 8th. X to the negative 12th and y to the 8th. Now what? Jessica?
I just have a question, like if there's a negative, do you still want us to switch the negative?
Oh, totally, totally, that's our next step. We are never allowed to leave negative exponents in our final answer unless it's scientific notation. Scientific notation is the only time that negative exponents are okay to end with. Now, they're part of the problem, so I have to deal with them, but I could never stop here, ever. Okay, so what am I going to do with those negative exponents? Personally, I'm going to move them. I heard somebody say, you got a division problem, Mrs. Ford, you can subtract exponents. Absolutely. That's not my personal choice, remember? Everybody gets to choose to do the problem however he or she wants. I'm going to move them. So I'm at my y to the 12th, x to the 8th is coming down, x to the 12th is going up, and y to the 8th stays down there. Is that okay with everybody? You may or may not have done the problem that way, but does that make sense to you? Now what happens? We're not quite done. Now I can subtract exponents or just use my common sense. I've got 12 x's over 8 x's. Who has more, the top or the bottom? The top. How many more? 4. So I've got x to the 4th on the top. And likewise, I have y to the 4th on top. So my answer is just x to the 4th, y to the 4th. Okay? Now we're going to find out that lots of the work we do this year is going to have more than 1 or 2 steps. We can't be intimidated by that. We just have to, one step at a time, get it done. We can do it. All right? One more. Let's do one more homework question.
50.
50. What is with all these exponent problems? 2 over xy to the negative 3rd. Okay, we talked about this, well, we didn't together, but certainly it was on your video. What happens when you have a fraction, a whole fraction, raised to a negative power? What happens to that fraction?
Flip it.
It flips it. Now, why does it flip it? It makes perfectly good sense, kids. When you have a fraction to a power, you take the top to the power and the bottom to the power. Wouldn't they both be then, wouldn't the numerator have a negative exponent and the denominator have a negative exponent? Yeah, and then we'd have the same situation we had here. Then it goes to the top and it comes to the bottom. The whole fraction just flips over. So I have xy over 2 to the 3rd power. Remember, when you flip the fraction, the exponent's going to become positive. Right? Okay, so what do I end up with then? What do I do with that exponent? Distribute it. That's really, I use that word, it's okay, it's really not the right word, but that's what we're doing. We're applying this exponent to everything. So it's x cubed, y cubed over, be very careful, do not put 6, that would be the wrong answer. What goes in the bottom? 8, very good. 2 cubed, 2 cubed, 2 times 2 times 2. Okay, I need to, did everybody fill in my seating chart? Is it being passed around somewhere? Everybody find it, okay? Where is it, over here? What's that sheet? Okay. All you late people, did you sign it? So I'm just trying to learn your names. So until I get your names learned, this is where you have to sit, then you can move after I get all everybody's names figured out. Okay, Maria.
Here.
Did you get your paper signed by Dan? It's okay, you keep it, I'll trust you, you wouldn't lie to me, would you? Catherine Klein.
Oh, here.
Did you get your paper signed? Okay, you did?
Yeah.
Okay. Madeline, did you get, oh, you didn't get paper. Okay, you need to bring this back signed tomorrow for full credit. Okay, Marilyn or Madeline?
Thank you.
Stemler? I'll get your paper signed. Where's Stemler? You're on now. Who's Stemler? He's not here today?
I didn't know we had home.
Super. All right. Okay. Get out a half a sheet of paper. Okay, we're pairing up, so you two are a team, you two are a team, you two are a team now. We'll let the tables agree, you can just be a team. You two, okay, yeah, that's right. This side of the table, and that side of the table. Okay, you guys are paired up across from each other, so 2, 2, 2. 2 and 3, okay? All right, so everybody's got a half sheet of paper out, our notes are put away, our books are put away. All we have out is a half sheet of paper. We're going to play a game up in the upper right-hand corner.
Do I have to carry our team?
Now, if you are a table team, you can stay at your table. If there are 2 teams or more at your table, then only one team can stay at the table, and the rest of you have to find a place. So you come up here, you go in the closet, come up here, go over there, I don't care, go to the comfy chairs in the back. Now, here's the deal. I'm going to give you 3 questions, okay? You get to work with your partner or partners on the questions. Everybody turns in a paper and nobody can talk. So you have to hand signal each other, write stuff down, but nobody talks. Do you understand the rules? All right, here are your questions. No. We are not using notes. We are not using our book. This is a quiz. We should be able to do this. And if you can't do it by yourself, you at least have your partner. And if the 2 of you can't do it together, then I don't know what to tell you. All right, so everybody split up. Okay, here we go. Remember, no talking. Here we go. When you are done, I want you to turn your paper over. I have one more thing to tell you. So when you're finished, just turn your paper over and sit quietly for a moment. about another minute. Okay, now while you're finishing up, here's what happens. Every time we have a quiz, I will ask the question, does anyone want to use his birthday bonus today? And what that means is, once this year, one time this whole year, you are allowed to ask a question. And normally we do it on your birthday, or as close to your birthday as we can, hence the name birthday bonus. You can ask any question you want. The whole class is gonna answer it for 2 points. So in a class of 28, I'm basically gonna give you 56 points this year, because the question that you ask has to have to do with math, but it doesn't have to be pre-calculus math. So a very typical question would be, what's 2 plus 2? Any math question worth 2 points. If we have a quiz on your birthday, and you use your bonus on your actual birthday, then it's worth 4 points. So if your birthday is yet to come, you want to save it. If your birthday is past, let's say your July birthday, then you might as well ask it. So, does anybody have a birthday today? Does anybody have a birthday in August up to today? So the first 10 days in August, any birthdays? Anybody have a July birthday? Do people reborn? Ronald, when's your birthday?
July 9th.
All right, you're using your bonus today. Ask your question. Any question. Birthday bonus answers go up under your name with a circle around them. So your name, remembers, in the upper right-hand corner, right? Here comes the question. Anything about math, any question at all you want, any math question at all. Well, your friends will like you more if it's easy.
Okay. What's 1 plus 1?
1 plus 1 is your question. Up by your name with a circle around it. Now, she has asked her question and she can't ask anymore. That's it. Everybody gets one chance. She's the first one. We're done.
Can you write the question out too?
No, just write the answer. Okay, got it? That's worth 2 points. All right? Okay, let's pass your papers up if you would, please.
We got one. Wait, they wrong.
You guys go back to the seats. Next time, some pair has to.
Oh, I never get to use it ever again.
I should never use it ever again.
Okay, I need all the papers. Let's go. We got work to do today, folks. Let's go. All right, let's get these on the board. Anybody feel confident with number 1? Anybody confident with number 1? Okay, Maggie, thank you. Let's just go up and do it. Anybody confident with number 2?
Yeah.
Should we put it under? Start. Go ahead, anywhere you want. Why don't you put yours above? Yeah, and then, okay, and then anybody get number 3? That was my tricky one. Anybody get number 3? Good. Of course you do, man. You're not surprised.
Like I said, don't even, you gotta just pick.
Right, just pick you. Anything that you ever turn in goes in this plate right here. Okay? Anything you ever turn in, late homework or anything, that's where you put it. Never put anything on this table because it gets lost.
Is that right?
I don't know, we're gonna talk about it in a minute. Why would you ask? Yeah.
She didn't want to stop with that, though. She said, I think I talked about it.
Our shirts all tucked in. Dark, what are you doing, man? Okay, kids, what do we think about what's on the board? How does this picture look to everybody? You may have put an open circle there. Everybody okay with that? All right, how about Stark's work here?
Yes.
You may have done it in a different order, but how does that answer look? He's got what the teacher, oh, no, he doesn't. Yes, he does. He's got what the teacher has, so I guess that's right, huh?
Why?
And additive identity? Yes. The additive identity property says if you add 0, you get the same thing. If you did this, that is not the additive identity, that is the additive inverse. You'll want to get those properties straight in your mind. Okay, now we got some stuff to do. Got to get busy. So let's get our notes out and let's do a review.
Why is your pocket so full?
Who knows? Okay, what's this called right here? Anybody know the official name of this? Cartesian coordinate plane. Anybody know who it's named for? Rene Descartes, great philosopher and mathematician. These 4 pieces of the plane, like the blackboard would be the plane, when you put the 2 axes on there, and this of course is the x-axis and this is the y-axis, right? When you put them on there, it divides the plane up into 4 pieces. What do we call those 4 pieces? Quadrants, right? Quadrants. And the quadrants are numbered like this. It is important that you get this down because, for example, I mean many reasons, but when we study trigonometry, we'll say things like, in which quadrants is the cosine positive? Well, if you don't know where the quadrants are, you're not going to be able to answer that question. What do we call the point of intersection of the 2 axes? The origin, absolutely, as long as we're in rectangular coordinates, we call it the origin. Super. Okay. What if I named 2 points in the plane? Let's say the point 2, 3. And remember, whenever I identify a point, it's x, y, right? And then let's say another one, how about -2, 1? And I said to you, what is the midpoint of the segment joining those 2 points? What would the midpoint be? Do you remember how to find the midpoint? It has nothing to do with measuring and counting. We're not going to do that. We're going to use algebra. How do we find the midpoint? Jessica?
Is it x1 plus x2 over 2, y1 plus y2?
Exactly. That's called the midpoint formula. Mrs. Ford is not very good with memorizing things. So I remember midpoint is average. And how do I average things? You add them and divide by 2. What does the midpoint formula tell you to do? Add them and divide by 2. Midpoint is average. So if I'm going to average my x's, -2 plus 2 is 0, divided by 2 is 0. So my x-coordinate is 0. We are adding the x's and dividing by 2. Now I'm going to add the y's. I'm going to average the y's. 1 plus 3 is 4, divided by 2 is 2. So one more time, how do I find the midpoint? I add them and divide by 2. I average them. What if I said, this is point A and this is point B, and I said, what's this? Now that notation, you've got to know, that notation means the distance from A to B. In other words, the length of segment AB. Notice there's nothing written above it, below it, around it, nothing. It just says AB. That always means the length of the segment or the distance from point to point. Anybody remember how to do that? Strike.
Isn't it like x minus y squared, or is it x plus y squared? Or the square root of...
Square root. It definitely involves a big square root.
And then is it x minus y?
There's some minuses and some squaring going on, but we want to be careful. It's not x minus y.
x1 minus y1.
It's x minus x and y minus y. So we had all the pieces there. That's good. We just didn't have them quite in the right order, but that was exactly right. We got a big radical. We subtract our x's and square them. We subtract our y's and square them, add them together, and take the square root. So for our example, here we go. -2 minus 2 and 1 minus 3. Now I want to point something out. Since I'm going to square the differences, I'm going to subtract and then square. Does it really matter what order I subtract in? No. So we're not going to get all hung up about that. Sometimes instead of doing 1 minus 3, I prefer to do 3 minus 1 because I like positive numbers better. It makes no difference. You're going to subtract and square. So what do I get? -2 minus 2 is? -4 squared is 16. 1 minus 3 is squared. Answer is root 20, except I'm an anal math teacher, and unfortunately you're in my class, so we're going to reduce every radical we ever find that reduces. So the square root of 20 is 2 root 5. And we remember, for those of you that may have forgotten, 20 breaks down into 4 times 5, which is 2 times 2 times 5. I'm taking the square root. I'm looking for groups of 2. The square root of 2 cubes is 2 root 5. Everybody remember the distance formula now that we've talked about it? Okay, next. Let's suppose I gave you an equation that looked like this. Would you have any idea, could you remember what that equation is?
Is that a...
It is a circle. Very good. That's the equation of a circle. What do we know? What do we want to know about circles? We always want to know the center and the radius, right? That's all there is really to know about a circle. So anybody look at that equation and tell me the center? Mr. Strive?
3, 4. 3, -4.
3, -4. My center is at 3, -4. For those of you that have forgotten that, just look at this parentheses right here. What would make that 0? 3. What would make this 0? -4. Whatever makes those 0, the opposites of these two numbers, that's going to be your center. What's the radius then? Grace? 5. And you know the radius is 5 because it's the square root of 25. Your radius comes by taking the square root of that number. Now in a later chapter, you'll remember the ellipse, the hyperbola, and the parabola. Remember, we'll talk about circles a little bit then. But circles are fundamentally just the distance formula, so they're included in this section too. What if I said, write the equation of the circle, given the center is 2, 4, and the radius is 8. Could you do that? Could you write the equation given the center and the radius?
Yeah.
What would that look like? Mackenzie?
X minus 2 squared plus y minus 4 squared equals 64.
Perfect. Absolutely perfect. Everybody on board with that? But of course, stuff in pre-cal is never that simple. Let's suppose the question says this. Write the equation of the circle with a diameter whose endpoints are 2, 4 and negative 6, 8. Now, Mackenzie just wrote the equation of a circle for me. She did that real easily. She didn't have to show any work or anything. She just said, hey, look, this is what it is. But in order for her to do that, what information did she have to know? The center and the radius. So somehow in this mess, you've got to get the center and the radius. So let's visualize this for a minute. Here's our circle. Here's our supposed to be a diameter. This is the point 2, 4. This is the point negative 6, 8. Somehow you got to get the center and the radius out of there. How do you think we might do that using some of the things that we've talked about? Those people are the only ones that are talking back there. I need somebody from this table to talk. Go, artists. I need to find the midpoint, because what's the midpoint going to give me? Well, it's going to give me the middle. It's going to give me the center, right? That's how I'm going to get the center. So, Nick, how do I do midpoint again?
X1 plus X2 over 2, and then Y1 plus Y2 over 2.
I'm going to add them and divide by 2. So what's 2 plus negative 6?
Negative 4.
Divided by 2?
Negative 2.
What's 4 plus 8?
12.
Divided by 2?
2.
So my center is negative 2, 6. So would you agree that I can already write this much of my circle?
Yeah.
All right, O'Malley, what else do I need?
Distance.
I need the radius, and I'm going to get that by doing distance. How would you like to do that?
Take 2 of the points,
Which 2 do you want to use?
the far left and the middle.
These 2?
Yeah.
So you're going to find this distance right here. Could somebody else find this distance right here? Could somebody else even find this distance and divide it by 2? Math rocks. Options all over the place. O'Malley's decided he's going to go this way. Okay, so the radius will be, all right, help me out. What do I write? O'Malley?
Negative 2 minus 2 squared plus 6 minus 4 squared.
So negative 2 minus 2
Negative 4.
squared.
16.
Perfect. 6 minus 4
2.
squared.
4.
So that's root 20. Now this time I'm not going to reduce it. Easier if I don't. If the radius is root 20, what's going to go here in my equation? 20. Because remember, in your equation, it's x is squared, y is squared, r is squared. This is r squared. There it is. Beautifully done. All right, let's take a look in our book. A couple of things I want to pay attention to in the book. Would you open up to page 22? Okay, everybody on page 22. If you don't have a book yet, you need to look at somebody's. Read our book every day, people. Books are important. Page page 22. Let's look at number 37. I am not going to do it. I want to talk about how you would do it if you had to do problem 37. Tell me, how are you going to prove that a figure, that they're giving you 3 points, how are you going to prove it's an isosceles triangle? All the sides are equal? Isosceles would mean 2 sides equal, right? So how would you do that? If all they gave you are these points, Gracie?
Do the distance between all the points and make sure two of them.
Exactly. So you're gonna do your distance formula here, your distance formula here, and your distance formula here, and you gotta have 2 of them match, right? Everybody good at that? Easy enough. All right, let's take a look at 39B. Now 39A says, okay, here's this triangle, okay. Find the lengths of the sides, we just talked about how to do that. 39B though says, show that it's a right triangle. How are you going to do that? And do not say, it looks like a right triangle. That is not an acceptable answer. How are we going to find out if we have a right triangle, Lane?
Find the distance of each side and make sure that it's like a squared plus b squared plus c squared.
Exactly. Did you hear what he said? He said, we've already in the problem, we will have found these lengths. So we'll have this one, and we'll have this one, and we'll have this one. We'll have those lengths already. That's part A. If this is going to be a right triangle, then this squared plus this squared has to be this squared, right? What do we call that? What rule is that, or what theorem is that? Pythagorean, exactly. If you want to prove something's a right triangle, you're going to use the Pythagorean theorem. Okay, number 49. All right, this is a little bit different. The distance between x and 4 is 3. All right, I need you really to pay attention to this. You may have never thought about this before, and it is a pretty important concept in the calculus, so I really need you to try to focus in here. Let's take a number line. And let's suppose I said to you, how far is it between these 2 points? What's the distance between those 2 points? Now that's an easy question, right? Even on Monday morning, we can get this one. What's the distance between these 2 points? 2. And how did you do that? Subtracted, right? You subtracted. Now here's the deal. Does it matter whether I do 8 minus 6 or 6 minus 8? No, as long as I take the absolute value. Distance on the number line is simply the absolute value of the difference. Now, I'm not asking you to memorize that. You already know it. You just did it. If I want to know how far apart these are, if I want to know what the distance is on the number line, I subtract. That's difference. And depending on the order I subtract, I got to make it positive, so I take the absolute value. That's easy. So if the 2 numbers on the number line, instead of being 6 and 8, suppose they're x and 8. What would the distance between them be? Absolute value of x minus 8? Or 8 minus x, right? Doesn't matter, I like to have my x come first. So when a problem like number, whatever that was, 49, is that what I said, says the distance between x and 4 is 3, the distance between x and 4, how do we do that? The distance between x and 4 is x minus 4, is 3. There's the equation in absolute value that expresses that idea. Let's try another one. The distance between x and 7 is more than 2. Could you express that as an absolute value? right? How do we do the distance between x and 7? Absolute value x minus 7 is more than 2. Got it? Now here's the really cool thing, people. It works backwards. So if you found an inequality that looked like this, what does this say? What is this talking about? The distance between x and 2, and it has to be less than 6. So think about that for a second. Here's my number line, here's 2. The distance between some number, some unknown number, and 2 has to be less than 6. So what's the farthest out that number could be? If the distance between these two has to be less than 6, the farthest out it could be is
4, 7. 2 is 7.
8.
Oh, just keep.
What's the distance between 2 and 8? 6. So as long as I'm somewhere in there, I'm going to be less than 6 away, right? How about back this way? Because we could go either way. What would be the farthest back it could go here if it has to be less than 6 units away? -4. So the number I'm looking for has to be somewhere in there. Okay, you guys aren't good for myself. You act like you can't wait to get out of here. Your homework's online. Make sure you do it, people. Have a good day. Hey, let's be on time tomorrow.
Although I think Katie, next week I gotta share this.
At least it's on time because I didn't do it.
And then I was late. Because all the time.
He's got a lot to say about you.
She wasn't wearing her bracelet. Yeah, I sat on her keychain. She's like, am I big
He will not stop talking to me. Like, I think I am his best friend.
really crying. No, but I have to go through Latin, which I'm changing my schedule.
Dude, I could drop Spanish.
I'm not going to take her. I think it's Spanish cold. I don't have resources. Where's yours?
Oh shoot, I bet that video is still running. That's not good. Yeah, we got some